Welcome to our introduction to testing in Python, a crucial skill for any developer. Our goal is to understand how testing helps in ensuring the reliability and robustness of your code. Today, we'll delve into the key concepts that form the foundation of effective unit testing. These are the fundamental elements you need to understand for building robust and reliable test suites. Let's begin by defining what we mean when we talk about test cases. Test cases are single units of testing, checking specific aspects of a component, usually implemented using Unitest. TESTCASE. Moving on, a test suite helps us organize multiple test cases effectively. It's a collection of test cases organized to run together, which greatly aids in collective test execution. Next, we have the test runner, which executes your tests and reports results. The test runner orchestrates the execution of your tests and reports the results provided by the Unitest module. Finally, assertions are the core mechanism for verifying expected outcomes. Assertions are methods verifying test output against expected results, like a SSERTEQUAL or a SSERTTRUE for verification. Now, let's learn how to actually write a test case in Python using the Unitest framework. We'll examine the basic structure of a test case and look at some simple arithmetic examples. Here, we define what constitutes a proper test case within the Unitest framework. A test case is a class derived from Unitest. TESTCASE. Methods starting with test represent individual tests and self. A SSERTEQUAL verifies value equality. This code shows a TESTM, a THOPER, a TIONS class with test addition and test subtraction methods, using a SSERTEQUAL to verify basic arithmetic. Once your tests are written, the next step is efficiently running them in Python. We'll explore how to execute individual test files and how to discover multiple tests automatically. Direct execution means running tests from a single file by simply specifying its name in the command line. Test discovery automatically finds and runs all test files within a specified directory for convenience. Verbose output provides more detailed information in your test results, which is incredibly helpful for debugging. Let's dive into implementing test fixtures, a crucial concept for managing your test environments effectively. This involves the important process of setting up necessary conditions before tests and cleaning up resources afterward. We will explore the SETUP and TERDOWN methods, which are fundamental for managing test fixtures in Python's Unitest framework. The SETUP method runs before each test to prepare the environment, while TERDOWN cleans up resources after every test execution. This code shows SETUP creating a database connection and TERDOWN closing it, ensuring a clean state for each test. Now, let's explore the core principles of test-driven development, a powerful methodology for software creation. At the heart of TDD is the red-green refactor cycle, a systematic approach to building robust software. The first step is to write a failing test, clearly defining the specific requirement or behavior you want to implement. You start by defining a specific requirement or behavior by writing a test before writing any actual code. Next, run this new test and confirm it fails. This validates the test and shows the feature is currently absent. Execute the test to confirm it fails, ensuring your test is valid and the intended functionality is not yet present. Then, write only the minimum amount of code necessary to make that failing test pass, nothing more. Implement just enough code to make the failing test pass, keeping your codebase focused and concise. Once the test passes, improve your code structure and clarity through refactoring without changing its behavior. Improve the code structure and clarity while maintaining its functionality, now that the test successfully passes. Finally, you repeat this entire cycle, continuously iterating through testing, coding, and refactoring for incremental development. Continuously iterate through writing tests, coding, and refactoring, enabling incremental and robust software development. Let's walk through a practical example of the test-driven development workflow to see it in action. We will explore a step-by-step practical walkthrough, illustrating how TDD guides your development process. The first step in TDD is to write a test that describes new functionality and is expected to fail. Next, run this new test and confirm it fails, ensuring the test is valid and the feature isn't built yet. Then, you write the minimal amount of production code required to make that newly written test pass successfully. After writing the code, run all your tests, including the new one, to ensure nothing else broke. Once all tests pass, you refactor your code to improve its structure and readability without altering behavior. Finally, you repeat this cycle for every new feature or bug fix, ensuring continuous quality and design. Let's explore the significant benefits that test-driven development brings to your software development process. We'll discuss why adopting a test-first approach can lead to higher quality, more maintainable, and robust software. TDD helps catch bugs early in the development cycle, significantly reducing the cost and effort of fixing them later. Bugs are caught early because tests continuously validate functionality as you develop, ensuring immediate feedback. TDD encourages writing minimal, focused, and efficient code, naturally leading to improved overall code quality and readability. TDD encourages you to write minimal, focused, and efficient code, leading to cleaner and more maintainable solutions. Writing tests first forces you to think about the design and interface of your code, resulting in better software architecture. By writing tests first, you naturally arrive at more thoughtful and structured software designs, enhancing modularity. A comprehensive test suite provides confidence to refactor your code safely, knowing that tests will catch any regressions. A comprehensive test suite enables safe code refactoring, letting you improve code without fear of introducing new bugs. Tests serve as excellent living documentation, clearly describing the intended behavior and usage of your code. Your tests act as living documentation, precisely describing the code's intended behavior and how it should be used. Let's now recap everything we've learned in this module about testing in Python, beginning with a summary. We'll focus on the essential key takeaways that will help you in your Python testing journey. Remember, unit testing is crucial for isolating and validating individual software components, often using frameworks like Python's Unitest. We covered key concepts such as test cases, test suites, test runners, and assertions, all vital for thorough verification. The Unitest framework also offers helpful methods like SETUP and TERDOWN for managing your test environments effectively. Test-driven development, or TDD, is about writing tests before your code, following that red-green refactor cycle. TDD helps detect bugs early, improves code quality, leads to better design, and gives confidence for refactoring. Always follow best practices by writing independent, simple, descriptive tests and automating their execution for efficiency.